Okay guys, this video is for example 4. Y equals x to the power 4/5 fails to be differentiable at x equals 0. Tell whether the problem is a corner, a cusp, or a vertical tangent, or a discontinuity. Okay, so you have to do that proof first, and then we will go over the summary of all the culprits. Okay, so let's do the right-hand limit and left-hand limit to see where it takes us. Left-hand limit, okay? So by definition, it's limits as h approaches 0, okay, from the left of this function. So we're going to go f of, and it says that x equals to 0. So we're going to go 0 plus h minus f of 0 all over h. Hi, Karine. Then from here, we're going to do this one step at a time. Then f of 0 plus h is just now f of h. Okay, take away f of 0 all over h. Then from here, we have 0 raised to any power is going to be 0. So just really limit as h approaches 0 from the left of f of h. Then I would just plug in h now for x. Okay, so limit as h approaches 0 coming from the left as h to the 4/5 power all over h. I'm sorry, this is not all over h as well. Then keep on going some more. I'm just gonna subtract because we're dividing numbers or variables the same basis. So when I subtract, this is now 1 over h to the 1/5. Okay. So as h approaches 0, this is going to give me an answer of a negative infinity. Okay, so left-hand limit is now negative infinity. So let's try right-hand limit to see what that takes us. Right-hand limit. Okay. Now right-hand limit, the formula is limits at h approaches 0 coming from the right of the same thing. Okay, again, we are told to find at 0, so f of 0 plus h minus f of 0 all over h. When I simplify this, I'm still going to get down to here, so I'm just going to skip all the steps in the middle, and now I get to this location. Okay, so limits of 1 over h to the 1/5. Okay, well, the limits as h approaches 0 from the right of 1 divided by h to the power 1/5 is now a positive infinity. Okay, so by definition, as you can see this, one is approaching negative infinity, one is approaching positive infinity. So by definition, can you tell me if this is a cusp, a corner, vertical tangent, or discontinuity? Final answer? Okay. Since left and right hand limits have different infinities. You know what? That doesn't sound. Why don't we spell out? Since left hand limit is negative infinity and right hand limit is positive infinity, since left hand limit is negative infinity and right hand limit is positive infinity, this is a cusp at x equals to 0. Okay. All right, let's do a little bit of a summary of all the 4 things that make it not differentiable. Okay, so the first one is going to be a corner. If you have a corner, if the limits exist, okay, but just not equal to one another. So limits exist from each side, but not equal. Okay, then the next one is a cusp. Bless you. This means the limit is negative infinity. Limit is negative infinity on one side and positive infinity on the other side. Okay, then we have the third guy that makes things not differentiable is called a vertical tangent. A vertical tangent is when the slope does not exist. Slope does not exist, okay? That means both limits are positive infinity or both are negative infinity. Then we have the fourth guy. The fourth culprit, it's actually the easiest to identify is the word I'm looking for. It's a discontinuity. Discontinuity, okay? So when you can see that one or both side limits do not exist or does not exist, okay? Okay, so those are the four culprits of not having or the function not be differentiable. Okay, so what I would like for you to do before you call this a day is try these on your own. Okay, and then I will check them out the next time I see you.